Good evening, colleagues, staff, and by no means last but no means least, our guests. Welcome, because this tonight is the opening night of the public lecture series 2018. And we are going to be discussing what is a really important and topical topic, plastic pollution and the planet. Now, just to get a sense of why you might be here, how many of you saw The Blue Planet? Can I have a show of hands, please? Wow, well, I think that probably says it all about what your motivation might be. And we have got two great speakers tonight who will inform you, but they will also hopefully stimulate and provoke you thinking on this subject. You will get a chance to challenge them, just as Professor Leahy said, but at the end of the presentation. So please keep your questions noted down somewhere so you don't forget what they are until the end. So without further ado, I would like to introduce our first speaker. Susan Jobling is Director of the Institute for Environment, Health and Societies and a Professor of Environmental Toxicology. Her interests lie in how environmental contaminants affect the health of wildlife and humans. Her work over the last decade has focused on the ability of environmental contaminants to mimic chemical messengers such as hormones and alter functioning of the endocrine system, in particular the reproductive system. So Susan will, in her talk, give an overview of the problem of plastic pollution and some of the key issues that we face today in planetary health. Ladies and gentlemen, please welcome Professor Susan Jobling.
Good evening. So tonight, I want to share with you a rather personal description of how pollution of the sea by plastic affects all of us, and invite you to consider why you should care that in a little over 50 years, we have made and consumed enough plastic to coat the earth entirely in cling film. Think of that. And that through our own inadequacies, we have plastered the planet such that plastic pollutes every corner of the world's oceans. Listen to that. It is the beautiful sound of the ocean. My first memory of being by the sea is as a child, with my boots full of seawater, but also full of sand, standing at the edge of infinity, fascinated by the end of the beach and the beginning of the bay, how the sand below dropped away. At primary school, they tried to teach me to swim like a boat in the swimming pool, but I preferred to be a submarine, underwater, holding my breath for as long as I possibly could. Later on in life, I learned to dive, scuba dive, and entered the pursuit of understanding the unfathomable ocean, studying marine zoology to understand and classify the diversity of life beneath the waves. So my first love is really zoology. And then I went on to study water pollution to unravel how it is influenced by humanity. And more recently, studying how these changes we cause come back to bite us. I've always been fascinated by what lies beneath the waves. What is fact, what is fiction, and what is fantasy? It is fact that 97% of Earth's water is ocean. We are a blue planet. We live on a blue planet. If you think the ocean isn't important, remember it provides protein for 2.6 billion of the world's people as the only primary protein source. If you think it isn't important, imagine Earth without the ocean. Mars comes to mind. No ocean, no life support system, no life. With every drop of water you drink, every breath you take, you're connected to the sea. No matter where on Earth you live, most of the oxygen in the atmosphere is generated by the sea. Over time, most of the planet's organic carbon, one of the key building blocks of life, it's in all of your bodies, has been absorbed and stored there. The ocean drives climate and weather. It stabilizes temperature. It is a fact that a vast quantity of plastic is accumulating in our ocean and presents a significant emerging global threat to the health of the oceans, and to your health, and to my health. It is now being described alongside climate change, ocean acidification, and ozone depletion as a human disruption to the environment, so major that it is potentially capable of destabilizing our Earth's normal function. At least 8 million tons, and maybe up to 15 million tons of discarded plastics currently find their way into the ocean every year. That's the equivalent of one dumper truck, like the one that comes to collect your litter. Probably every Tuesday it comes to my house, backing into the ocean and dumping its load every year. Consider the fate of one of the plastic bottles lying beneath the waves here on the shore. I've got one here, an empty plastic bottle. That doesn't sound much like the waves, does it? So it's been bought, it's been opened, it's been consumed, and it's been unceremoniously discarded, lying poised at the end of the beach and the beginning of the ocean, having been blown there by the wind. It drifts off into the ocean after months lost at sea. This little bottle, let's say he's a he bottle. He's drawn slowly into a massive vortex. The bottle is not alone. Lots of other bottles and other plastics used to make disposable consumables, think straws, plastic cups, coffee cup lids, are trapped in this vortex. It is a fact that plastic debris primarily collects at 5 of these spots, these rotating currents called the gyres. The 5 or maybe 6 spots on Earth where rotating currents gather masses of plastic debris. But it is a myth that you will see mountains of yellow ducks, novelty sunglasses and the like, plastic cups there. What is there is perhaps not as alarming as Garbage Island or the so-called Great Pacific Garbage Patch, but a lot more dangerous. These plastics we use to make consumables are broken down by the sun, the waves, and by bacteria, microbes, until what is left is like garbage rafts, and more like tiny bits of confetti floating in a soup. And most plastics don't biodegrade, which means they're destined to break down into smaller and smaller and smaller and smaller pieces, called microplastics, which might rotate in the sea eternally. So in 1999, samples taken from one of these 5 gyres showed 6 times as much plastic as there was plankton. And 10 years later, that ratio of 6 to 1 had gone up to 136 to 1. 136 more times plastic than plankton by weight. So you have small pieces of plastic and large pieces of plastic in these floating gyres, and in fact all around the ocean, because the currents shoot off to different parts of our shores around the world. Some animals, like seabirds, turtles, and seals, will get entangled in the mess. Turtles and whales, they might even grow and develop with plastic wrapped around them, as in one of these photos. Or they might mistake plastic bags for jellyfish, in the case of turtles, or squid, in the case of whales. and birds mistake the brightly coloured plastic bits for other types of food. Mama birds take back to their nests and feed their young. Up to 300 pieces of plastic was found inside this bird, and indeed inside one 90-day-old chick. And that plastic, when weighed, counted for 15% of that bird's body mass. If we translate that into human terms, that would be equivalent to you or I having around 6 or 8 kilos of plastic inside of your stomach. If you can't imagine that, then think about pizzas. Most of us can eat one pizza. How many of us could eat 12 and have 12 pizzas sitting in our stomach? 90% of seabirds today have ingested plastic. Very small bits of plastic, the so-called microplastic, get eaten by plankton. Plankton don't smell or eat or see their food, so they don't differentiate between microplastic and microalgae, which are the small plants that they eat. Plankton get eaten by mussels, fish or squid, which get eaten by bigger fish and by whales and seals and dolphins. You know the nursery rhyme, you know, no lady that swallowed a fly. I don't know why she swallowed a fly. And then the animals get bigger and bigger and bigger, don't they? So they accumulate in the food chain. Plastic also accumulates other water pollutants on its sticky surface, such as PCBs and DDTs. These are persistent organic pollutants that we don't really use anymore, but they're still around even though they've been banned because they're so persistent. So we are part of this food chain. We're what we call an apex predator. We're at the top. A range of fish, crustaceans and shellfish species that are fished or farmed for the seafood market ingest plastic and potentially provide a direct route by which our plastic waste could be returned to us on our plates. So as a result of consuming contaminated oysters and mussels, one study estimated that the average European seafood consumer will consume 11,000 pieces of microplastic per year. Plastic bottles are drifting, fishing nets are sifting, the oceans are a mess. We need to try our best. To help our fishy friends, our fishy folk are dying. Baby seals are crying. There's trash among the kelp. These animals need help. Islands of trash are forming. Plastics are swarming. Fish are eating garbage. Their lungs and their stomachs are turning hostage to these vile microtoxins. Plastic is on the beach. You can hear the animals screech. Birds are eaten rotten. Trash is thrown to float. Caps get stuck in sea turtles' throats. Our oceans are too lovely to make them all turn ugly. Very small pieces of plastic, billions of pieces, are snagged on coral reefs. If you can spot the Nike logo in the corner of this slide, you will see plastic lodged in the coral. In a study published just last month, it was shown that 89% of corals in the Asia Pacific that were fouled by plastic were suffering from disease versus 4% on reefs that didn't have quite so much plastic. Small fragments of microplastic have lots and pits and pores that can harbour bacteria. So being cut by a fragment of plastic, if you're a coral, can be like the kiss of death to a coral, cut with a dirty knife. On the tips of the branches, just imagine, like the tips of your toes, and watching the gangrene spread up your legs to the rest of your body. This matters, not only to the coral, and not only because coral reefs are a wonder of the world and home to many spectacular creatures, subjects of TV series like The Blue Planet, but because they are also vital for 275 million people who rely on them for food, for coastal protection from storms, and for income from tourism. If algae or microbes settle on plastic microparticles, they go under, sinking like ships, airplanes, or a corpse down into the dark, at the bottom of the abyss. The darkest night reigns there. It is lightless, unless animals, such as this lanternfish, provide their own light. It's void of stars. Nothing sparkles. And yet, even there, plastic is found. The sediments contain inconceivable quantities of tiny bits of microplastic particles, mainly fibers from clothes, for example, polyester. Generally, these are about 2 to 3 millimeters long, so inconceivably small, but often less than 1/10 of a millimeter thick, even smaller in terms of thickness, the sum of which exceeds by 10,000-fold the larger fragments of plastic which you can see drifting in the polluted water gyres. More than half of these are actually viscose, which is not plastic, but it's an artificial fibre made from cellulose. And guess where it's used? It's used in cigarette filters, and increasingly in clothing. Some of these end up on the beach, of course, regurgitated by the sea. In fact, plastics now make up 60 to 80% of all marine litter, lots of which is found in the sand. The percentage is increasing at an alarming rate, and nowhere on Earth, whether you go to the North Pole, the Black, Red, or Dead Sea, the Caribbean, or the Antarctic, is there a large body of water, a coast, or a beach without plastic litter. It is perhaps fantasy that the primordial ancient ocean 4 billion years ago gave birth to the first organic molecules is undergoing a dramatic change, whereby synthetic molecules are taking over and turning it into a techno soup as a result of plastic waste. Or is it? I've been recently asked to contribute to a book called The Lives and Afterlives of Plastic. Could the afterlife of humanity, plastic waste, give birth to plastivores, better equipped than we are for the world we are leaving behind? Will there be birds subsisting on bottle caps, laying eggs like these that adopt the colours of corporations, like Tesco's and PepsiCo's? Perhaps a nice makeup brand I'd prefer, actually. I would prefer that. Balloon-eating plasticized turtles, perhaps. Bacteria-eating PVC excrement. Artists have imagined these things, and some are real and not imagined. Certainly there are chemicals in the ocean that arise from and leach from plastics, impurities of plastic that hitchhike on plastic into the oceans, and indeed fragments of plastic itself. There are plastic-eating bacteria and worms whose gut microbes have adapted to eat plastic. Did you know that the second most common material found in all marine creatures across the globe is polyester? Indeed, one could speak of polyester fish, polyester water snakes, polyester octopi. And perhaps once the particles are ground smaller and smaller until they condense with the seawater vapours and rise into the air, one will speak of clouds of polyester or viscose, plastic clouds. Fantasy? Maybe not. It is a fact that there is more than just water coming from your tap. A new study, published September 2017, found tiny pieces of plastics are contaminating more than 80% of tap waters sampled from a dozen countries. How is this so? Well, ironically, what has ended up in the sea originally began there too. Indeed, a future historian might say that the men of the hydrocarbon age busied themselves with extracting oil from the land and also from under the seabed in order to heat their homes and fuel their vehicles. But some of it they used to make plastic, an almost indestructible substance valued for its durability. Rapidly replaced materials like ivory, silk, tortoiseshell, thus saving lots of wildlife who were being hunted for these things. And it was hailed as a panacea. Bakelite, the first synthetic plastic, was created in 1907. And of course, the real boom didn't come until the mid-20th century. In the 1940s, cellophane was designated the third most beautiful word in the English language, after mother and memory. Since then, there has been an incredible rise in plastic production to reach the 300 million tonnes per annum we now make. That's close to the weight of the entire mass of the human population every year. This figure is going to grow with increased worldwide consumption. The fact is, plastic is useful and has become an essential part of society. In this century, we have produced more than the entire 20th century. Today, we're wearing it. It's on our shoes and in polyester and vinyl clothes. We turn it on for lighting, cooking, travelling in the lift, lighting the Christmas trees. We play it in the form of TVs, radios, video games. It holds our memory in computers and memory sticks, and it connects us to one another by being part of mobile phones, headphones, and chargers. Problematically, but also fortunately, it's wrapped around almost everything we eat and drink and other things we consume, in the form of packaging, Ziplocs, Tupperware, cling wrap lids. We sip it through bottles holding various beverages, including water itself. If you want to eat a biscuit nowadays, we have to buy a biscuit within a plastic wrapper, within a plastic tray, within a cardboard box, within a plastic foil, within a plastic bag. It's not hazardous nuclear waste, for goodness sake. It's a biscuit. Much of the plastic packaging is so cheap, it's designed to be used only once, and only a fraction of plastic produced is recycled or even recyclable. The rest ends up in the environment, your environment, either because it's discarded or because it leaks from litter bins or tossed over the side of a boat. So we are back at the beginning of my story with more than 8 million tonnes of plastic waste leaking into the ocean. That's about 15 plastic shopping bags worth for every metre of coastline. Or looked at another way, if you prefer weight rather than length, 18,000 Boeing 747 aircrafts at full capacity annually. Some areas of the planet leak more than others, it's true, but all areas leak. Going back to our lonely bottle, if it didn't escape the wastebasket, then it could end up in landfill. Like hundreds of millions of its brothers and sisters, these huge dumps expand each day as more and more trash comes in and takes up space. It's compressed among layers of junk, getting more and more squashed as rainwater flows through it and absorbs the chemicals that leach from it. Together they create a stew of leachate, which can move into groundwater, soil, and streams, contaminating ecosystems and wildlife. Plastic ending up in landfills can take hundreds of years to degrade, or thousands of years to degrade. Oh, how this magical substance has fallen from grace. So if you're sitting in your office drinking your bottled water thinking this is terrible and how you need to throw your little bottle in the blue recycling bin and not the white bin, then you have that real moral feel-good moment thinking I've been responsible. But if we were to follow some of these bottles on their journey, we would be shocked to discover that all too often they go on a boat all the way across the ocean to a developing country. I think we imagine that someone is taking our little bottle away and looking after it for us, giving it a little recycled bottle medal. But that's not what happens. What happens all too often, but not always, is it gets burned. In many developing countries, recycling means incineration, which often releases chemicals. Spare a thought for the waste pickers, people in poor countries, who for as little as $1 a day pick through stuff, extract what they can, mostly metals, and leave behind what they can't recover. They separate plastic by shape, by colour, by feel, sometimes using what's called the burn and sniff technique to separate different types of plastic. This may be a low-cost economic solution. It's certainly not a low environmental or human health and safety solution. Our health and ocean health are connected. We've got filthy ocean floors and dirty ocean shores. We need to start policing the garbage that's increasing. We need a total rethink of plastic in society. Rethink, reduce, reuse, recycle. We're familiar with the latter. Sure, some of our plastic bottles are to be spared the cruel purgatories of their brothers and sisters. They could be taken to a plant, squeezed flat, compressed into a block, The blocks are shredded into tiny pieces, they're washed and melted, and they become raw materials to be used again. As if by magic, they are reborn. Technological innovation is also part of the answer. At Brunel, we created the very first biodegradable plastic bag, perhaps ahead of its time, in the 60s. Our design students every year produce new ideas to recycle and reuse and reduce our use of plastic. Last year, one of our students visited a village in Sri Lanka and was inspired to make materials for a prototype sewage pipe from sand and the plastic that was mixed with it. There are many more examples I don't have time to show. But we also need to reduce our consumption and perhaps even refuse disposable plastics. Wouldn't it be fantastic if we stopped using plastic and eased the world's pain with a healthy food chain? Turtles would no longer gag on a supermarket's bag. Seabirds would have a meal of food that was real. Less chemicals in the sea would be healthier for you and for me. Let's move to a system where we don't have disposable anything, including plastic. After all, we don't have disposable resources, we don't have disposable species, and we don't have disposable people either. We don't have a throwaway planet. We don't have throwaway children. It's all precious. Thank you.
So now I'm going to introduce our second speaker, Andreas Kortenkamp, who is Professor of Human Toxicology in the Institute of Environment, Health and Societies at Brunel. His team has for over 15 years engaged in ways of improving risk assessments by taking chemical cocktail effects into account. His research explores environmental pollutants and their combined effect on endocrine diseases. Andreas will be furthering our discussion with a talk entitled "The Way We Handle Plastics and Toxicity is Dead Wrong." Provocative or what? Ladies and gentlemen, please welcome Professor Andreas Kortenkamp.
Good evening. Thank you very much, Mariann, for this introduction. The screening of the film The Blue Planet has meant that the great British public is really switched on about recycling, and it has really raised awareness about the plastic problem and the need for recycling. I'm here tonight to bring to you the idea that although recycling is good under certain circumstances, as currently configured in the UK and other countries, recycling may actually worsen the problem. And in this trailer, the last sentence you heard, the solution starts with us or with you. I think the solution starts on this photo there. What this photo shows is a production facility for vinyl chloride, which is the building block of polyvinyl chloride. In case you wonder what this is, your credit card will be made out of PVC, polyvinyl chloride. It is used in flooring, in piping. Many articles inside your cars will be made out of PVC. The production of this plastic has increased exponentially in recent years. Today we're experiencing about a 3 to 4% increase in production year on year. Let us have a brief look at how it's made, where it's from, and this will open up, I hope, a better understanding of the toxicity problem associated with this. It starts with chlorine. Chlorine is made these days by electrolyzing brine. a solution of sodium chloride, table salt. You're familiar with it. Initially it started, if you want to make caustic soda, which you need for the production of soap and various other useful chemicals, you need to split electrolytically the brine. Inevitably, it releases an equal quantity of chlorine gas, and initially the problem was for industry, how do we deal with the chlorine gas? Chlorine gas is extremely unpleasant, very toxic, difficult to store. And so the idea arose to use all the chlorine gas to chlorinate ethylene, which in turn comes from the petrochemical industry from the distillation of crude oil. The petrochemical industry sits on vast quantities of this. They not only make petrol, which we burn in our cars, but various other substances. It's a whole chain. So this was useful. So you chlorinate ethylene, you get vinyl chloride. And this was handled some nearly 100 years ago by a chemist, and he left it in a vial in the sunlight and came back. It was totally unintended, and noticed, oh, something has changed here. The stuff has turned itself into something solid. This was polyvinyl chloride, and initially people didn't know what to do with it. Because as such, the stuff is totally useless. It is very brittle. If you leave it in the sun, it gets nasty stains and so on. So how do we make it useful? And you see this here in the bottom half of this production chain. Naphtha, coming from distillation of crude oil, is also useful to make long-chain alcohols, which you then react to form plasticizer chemicals. And combine this with PVC, all of a sudden PVC is extremely useful. Your plastic bag from supermarkets is made out of polyvinyl chloride, but it contains a very large fraction of these plasticizer chemicals, so it's nice and bendy. The pipes used for water supply are also made useful by the addition of plasticizers, and your credit card is a little bendy. There are plasticizers in there. If that wasn't the case, if I did this, it would now break, and it wouldn't be a credit card anymore. So the problem with these plasticizer chemicals is, it turned out they leach out of the plastic and they affect our sexual development. You may know that the default trajectory of human development is female. To make a man during a certain period of fetal development, the action of male sex hormones has to kick in. If this doesn't happen, even genetically male subjects turn out to look like a perfectly formed female. And this leads me to the wonderful Jamie Lee Curtis, who I've always adored, and it was very disturbing to me to hear there are rumors on the web that really she's a man. There are individuals who suffer from a rare genetic mutation which affects the hormone receptor that relays the signal from the male sex hormone to other things and initiates programming. So if this receptor is mutated, the message from the hormone can't get through, and if this happens, genetic males turn into females. But really, of course, the rumors about Jamie Lee Curtis are false. She is really a woman. I'm telling you this story to show you the power of hormones in development. And now it turns out that many of these plasticizer chemicals used to make polyvinyl chloride bendy, in fact, drive down during a period in development in the womb the synthesis of male sex hormones. We have known this through painstaking research. At first, phthalates, these plasticizer chemicals, were thought to be safe. But then it turned out that the people who evaluate this had looked in these tests with animals at the wrong time. They exposed the animals at the wrong time. They threw most of the litter away, so didn't examine all the offspring. In short, the dangerous effect of phthalates was overlooked. Someone who I happen to know personally looked at it properly, examined all the offspring, and found the effect. And that set in train a really very productive research into the safety of phthalates, or rather lack of safety. Now, it has turned out that these chemicals, many of them are much more toxic than initially thought. And of course, industry reacts to this. What they did was they did the tiniest possible solution imaginable. Literally, they changed one little atom. So, it turns out that there is a change in effect, but very much to the frustration of myself and many of my colleagues, the task ahead was now, well, it has taken 20 years to demonstrate the dangers of these plasticizers. They change one thing. Will we spend another 20 years to show that this is now safe? I can promise you we will uncover more dangers or other things. But why this is important, I'm not arguing here that you touch plastic and you will turn ill. That is not the case. The problem with this is because plastic production is such super high volume, we need very high standards of safety evaluation for the chemicals which we have to add to plastics to make them usable. And that, in the long run, is unsustainable. It wastes a lot of useful brains in toxicology. Imagine the groan that went through the ranks of my colleagues when this happened. Do we really have to start all over again, and it takes another 20, 30 years to show whether these are safe or not? That is the problem with this story. These are really massive volumes we need, in the European Union, each year 900,000 tons of these chemicals are made, and most of them are just used to plasticide PVC. Let me switch gear. Polyvinyl chloride is very difficult to recycle. It is used in windows, pipes, floorings. They are high durable plastics. This is very cheap. People go for the cheap option. But at some point, there is the end of a lifetime of windows, pipes, and something has to happen. Landfill is often forbidden in many countries, and what does happen? This graph shows you statistics from Plastic Europe's. On the top, you see countries which have implemented a landfill ban. The recycling rates in many of these are quite okay. The blue graphs show proper recycling. The green ones. The blue ones show what is euphemistically called thermic recycling. What this basically means is you burn the stuff. You just burn it. The UK is somewhere down there. You see the recycling rates in the UK are not so good. In the UK, we burn a lot of plastic, but as you know, we've shipped a lot to China. 75% of all the plastic used in the UK was shipped to China. Now China has said, well, we've had enough, we don't take this stuff anymore, and now the pressure grows in the UK to do something about it. I promise you we will burn it. But I would like to argue now and explain to you that this burning of polyvinyl chloride is a big problem. Very much to the consternation of many people, it was shown already at the end of the 1970s that burning PVC liberates dioxins, polychlorinated dioxins, which are the most toxic chemicals ever made by man. Woman, I'm not so sure, but definitely man. It came to the fore in 1976 in Seveso when, during the production of a disinfectant for use on babies, hexachlorophene, a safety valve burned in this production facility during the night, and this released kilogram amounts of this super toxic stuff into the environment. And the consequences were drastic and tragic. The next morning, the sheep grazing in the vicinity were all dead, as you can see here, and humans, fairly quickly after the incident, developed a disfiguration of the face called chloroacne, as in this poor little child there. But that's not the only effect of dioxins. This has given rise to a lot of research. And today we know that long-term, low-level exposure to these chemicals gives you cancer, has an effect on thyroid hormones, drives them down, which is very important for healthy brain development, and has various other effects. When we burn, so this is 40 years worth of research which has uncovered this. We now today understand a lot about the toxicity of these chemicals. Burning PVC in municipal waste incinerators means only one thing. We know that this liberates these super toxic chemicals. It will continue to be released into the environment, and there's one lesson we've learned from these chemicals: they are very stable, they accumulate in our fats. All of us here in this room have these chemicals in our body fat. Once they are released into the environment, we cannot get them back. They are there. There's no way of collecting them back and cleaning up the environment. We just have to wait for a very long time until the levels slowly decrease. And they do, but we're plateauing off with these dioxin levels in your bodies and in the environment. And many of my colleagues and I believe that we probably will never really get rid of them out of the environment. So these are lessons we should have learned. Now, bringing back PVC, trying to recycle it, which means practically burning it, will exacerbate the problem, will make sure that this dioxin problem persists. So, here we are. The problem with PVC is the true recycling is not really technically very feasible. You can recycle other plastics, we make fleeces out of them and all these things, but with PVC, this is a big problem. Let's go back to the production line and think about other ways of addressing the problem. So it is very easy to discuss this with interested people and say, okay, you should recycle more. And if you don't, you know, there's a guilt-inducing thing. Oh, you haven't recycled today. I have these discussions with my wife. She makes me recycle, and I'm sort of knowing all this. We do recycle, but I'm not so motivated, because I think if we attack this problem from the end of that yellow box-labeled PVC polymer, this is hopeless. You cannot recycle PVC truly so the cycle closes. It is rather like it keeps being produced and you try, and it's sort of rather like a spiral which spirals itself to death. Because what we have to do, unless we address the problem at the root, it will just go on and it is truly unsustainable. So how about a ban on chlorine? Some people have discussed this. This would, from this diagram you will immediately see, will shut off the entire mass flow. How about a sunset on chlorine? I hear some people cry out, oh God, there's no PVC plastic. Well, but from the curves we showed you, think back only 20 years. There was half as much PVC around than we have today. The world didn't collapse. I remember 20 years ago, I felt quite well. This is, what I'm trying to tell you is this is a machinery which is driven by industry and by the desire for profit because the stuff is so cheap. It goes up and up and up and up and up. And Blue Planet is all well and fine. I recently, in preparing for this talk, read the market analyses for plasticizer chemicals. The industry is delighted. They are exuberant. They say, oh, good prospects for plasticizer chemicals in 2018. Yeah, expected rises in profits in the order of 3, 4, 5%. There you are. That's the machinery. We are locked in with this chemical industry mass flow into a juggernaut that keeps producing the plastic. Recycling is good, but as long as we don't address the root causes of this, I think all this will be leading nowhere, and all the appeals to please recycle are nothing but empty gestures. Thank you very much.